All right, let's just jump right into this explainer. Today, we're taking a completely mind-bending journey through astrophysics and quantum mechanics. But don't worry, we aren't going to just stare at dry math or dusty equations. We're going to explore the absolute extremes of our universe, from the crushing dark depths of black holes all the way to the literal paradoxes of time travel. And we're going to do it all using a cosmic stickman. So, here's our roadmap for today. First, the cosmic book theory. Then, gravitational time dilation, inside the black hole, wormholes and shortcuts, the grandfather paradox, and finally we'll wrap up with the many worlds interpretation. Okay, part 1, the cosmic book theory, how to read the fabric of the universe. To really wrap our heads around this stuff, I want you to think of the entire universe as a massive, readable book. In this framework, the Big Bang, well, that was the very first drop of ink hitting the paper, kicking off the whole story. Time is simply the turning of the pages. The light and matter that actually make up you, me, the stars, that's the ink. And gravity? Gravity is the physical weight of the pages themselves. And here is the kicker. The heavier the pages, the harder it is to turn. Now, to truly understand what happens when we start manipulating those pages, we need a volunteer. So meet our hypothetical stickman. He's our ultimate cosmic test dummy, and we're going to use him to visually stretch, tear, and fold reality so we don't get entirely lost in the math. Don't worry, he doesn't feel a thing. Well, we hope. Moving on to part 2, gravitational time dilation, experiencing relativity by comparison. So what actually happens when our stickman gets dangerously close to a massive gravity well, like a black hole? The sheer, incomprehensible mass of that black hole literally drags and stretches the fabric of space-time itself. Because gravity is just so intensely heavy there, the turning of the pages slows down to an absolute crawl. If we were watching him through a telescope back on Earth, we'd see him moving in agonizing slow motion. Plus, as that intense gravity literally steals energy from the light bouncing off his ship, that light gets stretched out into longer, redder wavelengths, a phenomenon we call gravitational redshift. Eventually, he'd just fade completely into invisible infrared, looking absolutely frozen in time. But, and this is the wild part, for the stickman, his local time feels entirely normal. It's only when he looks back out at Earth that he sees our time just flying by in high-speed fast-forward. He is effectively using heavy gravity to time travel right into Earth's future. And this brings us to a really profound realization. Gravity isn't just some simple force pulling apples out of trees. Like this quote perfectly highlights, gravity is the only pen that can write across dimensions. It actually warps the flow of time and the very fabric of reality. It makes the pages of our cosmic book so unbelievably heavy that the ink of time physically struggles to move across them. All right, part 3, inside the black hole, tearing the pages of space and time. So what happens when that gravity gets so extreme that it just breaks the rules of physics entirely? Going back to our book metaphor, a black hole singularity is essentially where the page becomes so insanely dense that it completely tears. All that mass is crushed down into an infinitely small point. And because of this infinite density, the escape velocity required to pull away from it actually exceeds 300,000 kilometers per second, which is, you guessed it, the speed of light. Since absolutely nothing in the universe can travel faster than light, the ink of reality gets totally stuck. The moment you cross that invisible boundary, known as the event horizon, light itself is trapped in this dark spinning loop, physically unable to ever radiate outward. But unfortunately, our stickman wouldn't survive the trip to actually see any of this. As he falls toward that singularity, the gravitational gradient becomes so steep that the pull on his feet is literally millions of times stronger than the pull on his head. This tidal force triggers a terrifying but very real astrophysical process called spaghettification. He'd be stretched out into a long, microscopic string of individual atoms way before he ever reached the center. But here is a fascinating twist. While black holes kind of seem like these dark, dead trash cans of the universe, they're actually the ultimate kings of entropy. Entropy basically being the cosmic measure of messiness and disorder. Stephen Hawking famously calculated that black holes actually store massive amounts of chaotic, 2D quantum information directly on their surface, on the event horizon itself. So they are essentially the ultimate cosmic hard drives, holding on to the scrambled, messy data of every single thing that ever fell inside. Let's jump to part 4, wormholes and cosmic shortcuts, folding the pages of the universe. Okay, so how do we avoid crawling at a snail's pace through those heavy pages of time? Standard space travel means moving linearly, right? From page 1 to page 2, all the way to page 500. And because of that pesky universal speed limit, covering those massive distances causes extreme time dilation. Thousands of years could easily pass back home. But wormhole travel, that changes the geometry of space completely. Instead of slowly walking across the pages, imagine just folding the entire book in half so that page 1 directly touches page 500. You basically poke a needle straight through both, totally bypassing all those linear pages of time for an instantaneous transit. And these shortcuts aren't just made-up science fiction magic. In the physics world, they're known as Einstein-Rosen bridges. They represent a real, mathematically sound solution right out of Einstein's equations of general relativity. In this scenario, space-time is bent so severely by gravity that it essentially tunnels completely through the fabric of the universe, acting like a secret backdoor to entirely different galaxies. Which brings us to part 5, the grandfather paradox, the Titanic time travel glitch. See, because wormholes can bridge vast distances instantly, relativity tells us they could also act as bridges backward through time. But this creates a massive, universe-breaking logic glitch known as a causal loop. Let's use the Titanic to really break this down. Okay, step 1. You use your wormhole to travel back to 1912. Step 2. You heroically warn the captain, you steer the ship clear of the iceberg, and bam, you save the Titanic. But here's the glitch. In step 3, because the Titanic arrives safely in New York, it's never recorded as a tragedy in your history books. Therefore, in step 4, the future version of you grows up in a world where the Titanic never sank, which means you have absolutely zero motivation to build a time machine to travel back in the first place. If you don't go back, the ship sinks. But if you do go back, the ship doesn't sink, so you never go back. It's a complete closed loop of contradictory logic. Because think about it, if the ink is already dry on the page, how on earth do you unsoak it? And that leads to our final section, part 6, the many worlds interpretation, the ultimate architect's perspective. To actually fix this timeline-shattering paradox, we have to look to quantum mechanics, specifically the ever interpretation, which most of us know better as the many worlds theory. This idea posits that every single time a quantum event has multiple possible outcomes, the universe literally splits. The wave function never actually collapses. Instead, all possible outcomes happen just in newly branching, entirely separate realities. So how does this solve our Titanic glitch? Well, when you travel back in time, you aren't actually rewriting the ink in your own book. You're traveling sideways into a completely parallel book. You save the ship, and in that specific, newly created universe, everyone lives. But when you return to your original universe, the ship is still sitting at the bottom of the ocean. You didn't smudge your own timeline. You just became a temporary guest in an alternate reality. Under this many worlds interpretation, infinite possibilities exist simultaneously. This means there is a branch of the multiverse out there where absolutely every potential outcome, every single choice you could have ever made is realized. You aren't just a passive observer sitting on the sidelines of a pre-written story. Through your choices, you are actively navigating the branching trajectories of reality itself. You are literally the architect of which exact universe you experience moving forward. So, I'm going to leave you with this final provocative thought. As we figure out how to fold the pages of the universe, and we start looking toward interstellar travel through wormholes, would you be willing to digitize your consciousness, your very soul, into pure information just to traverse this infinitely branching multiverse? Or are you perfectly happy staying right here on this beautiful, lucky little bus stop we call Earth? Thank you so much for exploring the source code of reality with us in this explainer.